All right, so for section 8.2, we broke it up into two parts. I broke it up into 8.2 part 1 and 8.2 part 2. So today we're going to do part 1. So the first thing we're going to talk about are these two vocabulary terms. So we have equations and two variables. So what that would mean is we have an equation, which we know what an equation is. It's a statement of equality. So an equation in two variables is a statement of equality with two variables or unknowns. Okay? So it looks something like this. 2x plus y equals 7. That would be a equation in two variables. All right? A solution to this would be a set of numbers or an ordered pair, because normally we're dealing with the x and the y, which is an ordered pair, that make the equation true. Okay, so that means when I plug them in, I'm going to get a true statement. All right, so let's look at example 1. In example 1, we're dealing with this equation here, so I'm going to rewrite that. 2x minus y equals 5. And they want to know, is this ordered pair a solution? So when I plug this ordered pair in, do I get a true statement? Well, in an ordered pair, the first number is always x, the second number is always y. So I'm going to take x and I'm going to plug it in for x. I'm going to take y and I'm going to plug it in for y. So this will become 2 times 1, because a number next to a variable, that means multiply, minus the y gets replaced with the -3. So we end up with a double negative sign here. Okay, and then we still have 5 over here. We haven't touched that. 2 times 1 is just 2. The double negative needs simplified into an addition sign, and then we have our 3 still. Alright, 2 plus 2 is 5. 5 is equal to 5. That's what you're doing the whole time. You're figuring out, are these two things equal? Well, 5 is equal to 5. Okay, 2 plus 2 is 5. 5 is equal to 5. So this point is a solution. It gave us our true statement. Alright. The other one, we're going to do the same thing. We just have a new point, but we still have the same equation. So I'm going to replace 4 and 7 with their variables. So x is 4, y is 7. So this will become 2 times 4 minus y gets replaced with the 7, and that's still equal to 5. Now you're going to simplify. 2 times 4 is 8 minus 7. Okay, again, we're figuring, are these two things equal? 8 minus 7 is just 1. Is 1 equal to 5? No, 1's not equal to 5. That's not a true statement. So this one is not a solution. Okay, so go ahead and pause the video, try checkpoint 1 through 4, and then come back to see if you get them correct. Okay, so you have, let me blow this up for you. For the first one, we replaced in our equation, we rewrite the same equation every time. The x got replaced with 0, the y got replaced with a 4, which became 0 plus 8. 8 is not equal to -8, so that is not a solution. For the second one, you replaced your x with the -2, the y with -1. So 3 times -2 is -6. 2 times -1 is -2. So that became -6 plus -2. -6 is -8. -6 plus -2 gives you -8. which is equal to -8, so that is a solution. For the third one, I would replace my x with 4 and my y with a -12. So this became 12 plus -24 equals -8. 12 plus -24 gives me -12, which is not equal to -8, so that one's not a solution. And the last one, the x got replaced with 10, and the y got replaced with -19. So that ends up being 30. 3 times 10 is 30, plus 2 times -19 is -38. 30 plus -38 is -8, and that one is a solution, okay? So if you scroll down and we look at our last problem here, this is just kind of like a precursor into what's going to be going on next. But what this problem is saying is, I don't need, well, let's just read it first. It says, in 1859, Mauna Loa eruption described on page 391, where they just talk about the explosion of this volcano. The lava's distance in miles from the ocean, T hours after it left the volcano, can be approximated by the equation of D equals 32 minus 4T. So they're saying this equation will tell you how far the lava is from the ocean. Okay, so basically what we have going on is we have a volcano right here, okay? I'm going to draw a little picture for you. We have a volcano, all right, and it's erupting lava. This is my lava. Here's my lava. Ooh. Okay. And this lava is flowing down the road and down the ground, and it's approaching the ocean, okay? So my lava's approaching the ocean. This is my ocean. What this equation tells you is how far, after so much time has passed, how far is this from this? So how far is the lava from the ocean after a certain amount of time? Okay? So, part A says make a table of solutions for the equation. So not make a table and tell me if these are solutions. You're making a table of actual solutions to the equation. So here's my table for part A. I'm going to have a column for T. I'm going to have a column for D. Okay, and I'm going to put a little space between them. And I'll tell you why in a second. Okay, so I'm going to make this table and go from here. So I'm going to pick some times that I'm going to use to determine how far it is. Because the time, how much time has passed, we can look at how much, any time period, a time frame, to see how far the lava is away. So we kind of get to pick the times. So I'm going to pick these ones. 1, 2, 3, and 4. All right. And then in here, I'm going to take that time and I'm going to plug it in right there. And I'm going to have an answer to my equation. So I'll know that these two are solutions because I'm going to take my T and plug it in and tell me when I plug in T, what do I get? Not, do I get the same as something else? No, I'm figuring out what do I get when I plug in this T value, okay? So for the first one, I'm going to take 32 minus 4 times 1. The T gets replaced with the 1. So 32 minus 4 times 1 is 4. So what is 32 minus 4? That's 28. Okay, then you're going to repeat this with the second one. 32 minus 4 times 2. That becomes 32 minus 8, which is 24. Keep going. So this will become 32 minus 12. That's 20. And then 32 minus 4 times 4 would be 32 minus 16, which is just 16. Okay, so that takes care of part A. Make a table, made a table. Part B tells me how long did it take the lava to reach the ocean. So for part B, you have two options basically, all right? But what it means is, okay, the lava's flowing down the mountain and towards the ocean. They want to know how much time has passed when the lava gets to the ocean. So if the lava gets to the ocean, how much distance is there between the lava and the ocean? Well, if the lava's at the ocean, then the distance between them is 0. So that means we're looking for what t value makes the d value equal 0. Okay, that's what it wants us to know. So you have two options. You can continue this table. As you can see, every time we go up on the t, our distance is going down. But there's a shorter way to do this. Okay, so you don't have to continue your table until d hits 0. That is an option. Just keep going down the table until d hits 0. Or you could just take your equation that you were given of d equals 32 minus 4t. And they're saying you want to know when d is 0. Okay, so I'm going to plug in 0 for d. If that is the case, solve this. It's just an equation. Solve the equation. What time or what t value makes d equal 0? So I have 32 minus 4t. If I go back to my equation solving skills, I know I need to start with the addition and subtraction portion. So I'm going to get rid of my positive 32 first. Those are going to go away. And over here, I'm just going to have the negative 4t. And over here, I'm going to have negative 32. Then I'm going to get rid of the negative 4 times t by dividing both sides by negative 4. Those cancel. That leaves me with just t equals 8. So how long did it take the lava to reach the ocean? It took the lava 8 hours to reach the ocean. Okay?